Hello, everybody, and welcome to another Frame It Fridays. Tonight, we are going to be going over a little bit bigger of a custom home, not a tiny little shed like we did last week. This one is a one-story with a popped-up ceiling right here and pretty much one-story-ish everywhere around. So there's going to be a few things that are a little bit different in this one that we have not talked about on other houses, and we're just going to get right into it. Guys, my name is Sam, spelled just like that. And I am a guy who loves framing, engineering, and nerding out about the structural details of stuff. So I've got this beautiful house here that we're going to be going through. I'll give you a little tour of it. And yeah, let's just hop right into it here. So this is our roof plan. Okay, big one-story, tall ceilings in the front, tall ceiling on the back porch, big, tall 20-foot ceiling in the center of the house. All right, here's those clerestory windows laid out here. That thing is popped up right here in the middle. On the floor plan, this is basically what we got, okay? So we got, for the porch, you got 10-foot, 12-foot, 10-foot ceiling, 11-foot entry in terms of like the regular ceiling height, 11-foot entry, 10, 10, everything's 10. Back porch is 12 feet tall, and family room, 20 feet, okay? So this big box right here is 20 feet tall. That's going to pop all the way up. So that's what the house looks like from the floor plan. Let's take a look at some elevations here. Okay, front of the house looks like this. Okay, here's the tall 12-foot on the front. There's a 10-foot here, 10-foot here. We're going to keep an eye on plate heights for this one. Okay, so look at this front roof plane. This thing is starting at 11 feet. You probably, it's kind of hard to tell across the computer, but the whole front roof plate is 11 feet, and it goes up at a 412 pitch to the back. All right, so this guy up here, that's the 20-foot plate height for these upper roof. And then on the back side, we got that 20-foot plate height, okay, for the upper roof. And the back porch plate height looks like it starts up here at 12 feet, which makes sense because we got a 12-foot ceiling on the back porch. And then we have these this back roof plane, which I believe starts at 10-foot plate right here, and it goes up to the back. We have a custom plate height on this side, and looks like this bedroom plate height is 11 foot. So 11-foot plate height in the master bedroom here, but the inside's a 10-foot ceiling. So we're going to be talking about that. Okay. And then the sides, we got the right side. Nothing super crazy going on here. Look, that we brought the gable all the way forward. It does look like we have, oh yeah, we have brick all the way across this, but this little piece of roof is basically just sticking out, not doing a whole lot. But that is the right, this is the left. Not a whole lot crazy going on over here. Just a few little, we're going to have a little interesting pony wall here. We'll talk about that. We've seen that kind of thing before, though. Nothing super crazy. So them's the elevations. Let's go ahead and hop over to the roof plan. And we're just going to start working our way through this building. Top down like we always do. Okay. So for the roof, let's do this. We're going to have a few overstack pieces. We're going to have some simpler things. Let's talk simple first. Let's do that. Okay. So this center area of the house, this one's going to be easy because this thing is popped up. It sticks up above everything else. And these roof planes don't interfere with anything else. So they're the easiest to think about. So what would we think about if we were going to think about them? Well, there's a ridge down the middle. So we got to do something with that. Okay. Ridge is right here. And then our rafters, guess what? There's really nothing much they can do aside from just, we're going to send rafters down this way from the wall to the ridge. And we'll go down this way, wall to ridge. Okay. We're going to take our fancy dancy scale here. Tells us what scale and measurements and lines and cool stuff. Everything is almost drawn to 1/4 inch 12 when I'm drawing it, typically. And so I'm going to go to the 1/4 12 mark here. I'm going to see how far this walls go. Well, English is hard. Okay, so from the 0 at the wall up to the ridge. Oh, that is super nice. That's just a hair under 11 feet, which means I can use 2x6s, 24 inches on center in this little zone right here. So 2x6, 24 on center, and that would be Southern Yellow Pine number 2. Guys, go check the IRC code tables to check spans if you don't know how far your spans can go. So that covers the rafters in that little zone. That's super easy. But we do got to support this ridge. And so how are we going to do that? Well, rule of thumb is going to be 4 foot on center. We got a ridge holding a bunch of weight. Okay, so I'm going to put my scale on here. It's about 30-ish feet across. I'm looking for a number divisible by 4. I got 28 right here. Just kind of move the 28, and then I'll go here. I'll say 4, 8, 12, 16, 20, 24. There we go. So that's about 4 feet on center. I'm going to do this. I'm going to mark a circle, and the circle means I need to support the ridge at that point and put the brace somewhere. Now, here's the fun part. There's nothing in here except, here's the ceiling plan for this little dude. Just a big flat ceiling. So the most efficient way to frame this ceiling is probably not by running a beam all the way across this way, because that thing is spanning almost 30 feet. That's just too much. So we're going to be better off if we probably maybe either put one down the middle. That's about 20 feet. Yeah, I'm going to say 2, just based on the amount of area we got here. If you put one down the middle, it's still going to be doing a lot of work. So based on past experiences, I'm just going to divide up this area with 2 different beams. All right, so we'll go ahead and draw those over here on the roof plan. Let's see, they're approximately here. Oops, should I use a different color? Oh well. Okay, they're approximately there-ish. Splitting it into thirds. Wow, I could have done that better. Oh well. So now let's think about how high is the ridge above the beam right here. How do we know? How do we know? Well, what do we know? We know the pitch of the roof is a 412. We know the rafter starts at the wall at 20 feet tall, and it goes up at a 412 to here, and we were about 10 feet-ish up the roof. So let's do some simple math here. Okay, pitch is a 412, and we went, let's see, that's horizontal. We went over 10 feet, so we have to know this. We'd cross multiply, you could write 40 equals 12 times your questionable thing, and you would divide 40 by 12. And in this case, we're going to round because that's easier. So we're going to say it's approximately, we'll call it 3.5 feet. All right, so we got 3.5 feet of height to work with at the peak. What does that mean? That means that when we brace and our roof is pitched like this, we got a purlin on here and we have a roof brace. Here's a wall. Here's a wall. Okay. This roof brace cannot be more than a 45-degree angle from horizontal, which means if we are 3.5 feet up, we can go 3.5 feet over. That's the maximum we can reach with each one of these braces. So I'm going to take this and I'm going to look in here. I'm going to say, well, I happen to know that each one of my braces was basically 4 feet on center. So I'm just going to say that I can stretch these out, and I'd shift them over when I actually framed it, but like I can fit 3 braces on each side, and it actually works out pretty good. So that's actually that's pretty good, because that works out that we can split this into thirds and carry the whole ridge. So we're happy about that. That's pretty cool. That takes care of the center section. Let's move on to something else. Okay. What else do we got? Well, let's see. Got a big garage over here. That's going to be funny. Let's talk about this area back over here. Okay. What's going on in this area? We got a 10-foot plate of the roof going up to a 412. There's a ridge right here. Look at that. That ridge lands almost dead on a wall. That's super nice. I'm just going to put my braces on that right now. I'm just going to say, yeah, we're going to brace down this whole thing. Just put the weight straight down on the wall. Super easy. All right. Now, let's talk about rafters. We got to get from the wall to the ridge and be supported. Now, here is where you've got something new we have not talked about yet, and it might have applied in the past, but I've ignored it. When I see a big roof plane like this, I think to myself, spliced rafters. Okay. What is a spliced rafter? It's when this distance is too long and it's over like 20 feet, it's over like 24 feet, and you need to buy multiple sets of rafters and splice them together at a purlin support. Okay, now all kinds of engineers have different specs on, like, well, you got to overlap them by 2 feet each direction, glued and nailed and screwed with metal plates. Like, I've seen some crazy stupid stuff, but like basically you take one, you end it, you slap another one next to it, and then like the rafters on the high end are going to be on like an inch and a half off layout of the bottom ones. Okay, so because it's good, the whole thing's going to have to shift over inch and a half as you come up the roof. So how much length do we got? Well, the rafter technically goes to the end of the roof, and up here is like 27 feet, and we're at a 412 pitch, remember? So that's actually a longer line than the horizontal. So I'm pretty comfortable that if I split this thing down the middle, everything is going to work out with splicing my rafters here. Now, what I want to think about in as like a plan hole at this time is, what is my support length from 0 to the wall to here? It's 25 feet. Okay, so if I use 2x6s and I split it in the middle, that doesn't work because I can go 11 feet with the 2x6s, and if I do that twice, that's 22 feet, which is not enough. So what am I going to have to do? Well, I could bump up the 2x8s, 24 inches on center, and that would get me across because I could do a 14-foot span and a 14-foot span. Either one of those is good. And that's why I'm going to look at the rest of my roof and think, would a 2x8 benefit me across the whole house? So next thing I'm going to look at is the other big roof planes. Here, here, here. This is going to be entirely special because it's a big open area. And it's specifically because it's a 112 pitch. There's like no room to do any attic stuff in here, which means like all the members that make this thing, the ceiling and the roof are going to be big. Like they're either going to be 2x12s or they're going to be TJIs, like actual I-joists. And that's going to be a function of how nice and flat they want that to look. If it was me, I'd probably use I-joists for at least for the roof. So what is, okay, here, should I use 2x6s or 2x8s? All right, that's the question. From the ridge to the wall, I have a little bit over 22 feet. Okay, so I'd be pushing it. I'm too close to 11 feet if I split that perfectly in half. And so I know 2x8s here would serve me pretty well. I also happen to know that this roof plane is all continuous to this one. So it's all connected. This ridge is in the same place and this wall's in the same place across the house. So that's the same. And that's the same. Therefore, on these smaller patches, 2x6s would be fine. But I think on the bigger ones, I'm going to spec 2x8s. So what I'm going to do is I'm going to say, hey, 2x8, 24 on center here, 2x8 here. In this little zone, yeah, we're just going to do the whole roof plane, easy, even 2x8, because these are going to be overstacks. And that also allows us to do this as an overstack as well, because we can just shoot the whole thing across 2x8s, nice and easy. I think that's going to be the best way to do that. But, you know, I'm also not ordering lumber. Quick chat shout out for all the wonderful people in the chat learning stuff tonight on a Friday night. We got Eugene. Welcome, Eugene. Good to have you, man. Thanks for supporting the channel. You are a smart person for showing up here on a Friday. This is awesome. And we have the one and only Green Observer, the very source of all of the music that supports this channel. This man is a smart man as well, here ready to learn on a Friday night, folks. That's right. Some people are hitting the bars, not really, because it's only 7:44 p.m. here. And I'm probably going to go try some socializing skills when I'm done with this. But first, we got to talk framing because it's a Friday night. All right. So 2x8, 2x8, this whole thing, 2x8. Apparently I write the 8 before I write the by sign, okay? So we got that going on. Let's draw those purlin lines. Let's go ahead and do that with a different color because that would be more confusing. Actually, rafters were blue already, so let's do this with pink. All right, so 2x8s are going to go from the wall to the ridge. We got to support it right in the middle. So let's go about halfway. I want to use the walls that I have. So I'm going to do a dashed line there. Let's see. If I frame rafter from wall, now remember the rafters in this zone are going to go like this. They're going to go from this wall and they're going to land on a ledger on the wall that's the pop-up, which stops right there. So how long is that thing? Unsupported. It's under 14 feet. Okay, cool. So I like it. So I'm going to do that all the way down, and I don't need extra purlins in here, which means I'm just going to push this thing to, actually, I don't want to go farther because I need it. I still need it to work out. Okay, that works there. This will work out just fine right here. And oh boy, not really any good options in here. We're gonna have some funny business going on in here. We'll come back to this. Okay, so purlins and stuff. Now we have a purlin. We got this dude, all right? This guy right here. Now we got to support it with this guy right here. So we do that every 4 feet, approximately. I'm going to eyeball it because I'm a professional. Ladies and gentlemen, do not try this at home. Okay. Now look, we got a wall there. We got a wall there. There's a header for a door, but that's fine. A wall there. We'll brace to wall, 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 brace to wall. Cool. This side, we'd go about 4 feet on the center. And then I got a big garage. I don't have anything special going on here, so I'll just put these in here for now. I'm not going to set the weight down because I don't have anything to hold it up yet. But now that I think about it and I look at it, this is a big gable wall on this side. So I've got lots of wall height to work with. I got some attic space in here. I'm just going to do this right now while I'm looking. And we're going to make beams blue. I already made these orange, I know. But I'm going to try to differentiate a little bit here. Okay. So that, oops, that's got to go all the way to the wall. The wall's over here. Actually, there's this, oh, that's kind of annoying. Man, who designed this house? It was me. Okay, it's not that annoying. They're just gonna have to like chop off the end of the beam because of this roof plate. What's happening is the wall is right here. The rafter is right here. It goes up at a 412. And the beam is gonna need to be nice and tall. Okay, so they're gonna have to slice off the tip of the beam in order to get it to work. And most times that's okay. I'm not going to get into why that's okay most times because I don't want people suing me. But like, hey, it's a thing that happens and a thing that works most of the time. So those are braces are taken care of. These ones are super easy. We'll just set those down on the wall. And this side, oh, look at that. We got walls everywhere. Okay, brace, 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 brace. All right, that's good. So that means that we got 2 bites in this whole zone. They're all supported. So we're just going to check off this whole area. We're going to check off this whole area. We got to do the gables and stuff. Actually, these are going to be super simple. These are just like 2x6s doing this, hardly structural at all. These are just like some 2x6s doing this. This guy here, okay, it could be one of 2 ways. We could make these real hips and valleys and ridges, or we could make it an overstack. In this case, we're already building this whole thing out. We're already building this massive roof plane all the way across. So, you know, overstacking is a little bit of a waste of lumber because like you're building things on top of other things and it's kind of unnecessary. If I were to use this as real, I would need to put 1, 2, 3, 4 brace points in here. And I would need a beam anyway. So yeah, we're going to make it real. We're just going to make it real. So we're going to brace there. We're going to brace there. We'll brace there, brace there. And then somewhere, blue is the beam. Somewhere in the middle of all this mess, we will add another beam that crosses the garage. And we will, we'll have to double check. You know, the actual placement of that beam is going to be a function of how tall all these things are to catch all of them. That's going to come down to field verifying. But we got it. We'll throw one in there. That'll do it. So that covers this side. This is an overstack. This is super simple. Starts at a 10-foot plate, runs up, hits this roof. This roof was already framed before this porch was done. This was already framed with rafters doing this. See that? They're starting on the wall and they're going up and stopping at this upper popped up wall, which means that like this little portion in here is the overstack part. So what we would basically draw this and actually how we'd actually build this is we'd take these rafters. I'm changing colors here. We'd run them like this. We'd support each rafter onto the wall because that puts the weight from most of the roof, puts the weight down into the wall instead of putting the weight on the other rafters. We'd prefer not to load the rafters if we don't need to. So we would do that there. And we do the same thing over here. And this whole area is good because we did this purlin. And we'll come back to that. This one's going to be like this. This is an overstack, so these will just kind of do this thing. And I'll do this in pink. This side, it could do a few things. Okay, so either you could run a beam across here and keep all these rafters doing the same thing, or you might as well just build this wall taller and just adjust the geometry so that these rafters basically do this in that zone. And then they step back out. That's probably what I do. I just do math and then build this wall up a little taller, put a little pony wall on top, something like that. Okay. All righty. So we got those things going on here. Plates are simple, plates are clean. Let's talk about this little dude over here. So remember we saw this on the left side. Let me show you the left elevation again. Okay, left elevation, looking this way. This right here, I'm about to show you, is this right here. Okay, there's a little thingy, little pony wall up there. Now it's board and batten siding. There's no brick on top of the roof, but there is wall there. And so we're going to need to put something in there. And that is just fine. All of these things work. Is my camera, hold on, make sure my camera is showing. Yeah, I got to make sure I'm staying in the shot. All right, so right here, pony wall. So I would notate, hey guys, pony wall below right here, pay attention. And also, let's just, for the sake, we've already got a ridge going on here. Let's run a beam in this room from this wall to this wall. And that's the direction that's preferred because this is a gable, okay? Which means we have wall on that side and wall on this side that stick up and give us lots of attic room for a beam. See this? See how there's a bunch of wall here? So there's a beam that can be above the ceiling right here, no problems. So that's going to catch all the weight from that. The rest of this is super tiny, okay? 2x6 is 24 inches on center. This can be real or fake. It don't matter. You're going to put it's such a small area. You're going to put the weight on this. Now, I will say, pay attention to this guy right here. This little roof shape, this is key. This is a 10-foot plate roof, okay? This is balanced out at 10 foot. This is an 11-foot plate roof plane. It starts at 11 feet, which means as it comes over, it actually passes over this wall and it comes up into this roof area. And if you visualize what this actually does in space, it means that there are rafters. I'll draw the rafters. Okay, so this roof plane, this 412, has rafters that go from the edge all the way up to the ridge. All the way like this, right? Now, if they're spliced, but like this is what they're doing. And that would convert to a fascia board, obviously. Okay. So the question is, focus, people, focus. What happens right here and right here? Because the rafters were sitting on a wall and there is no longer a wall because you're now inside this bedroom. There's no wall right here. So what you're probably going to do, what I would do, is you could catch them with a beam and you could either push the beam over here, use a little hanger, or you could push the beam in line with the wall and just like adjust your framing and geometry numbers. You could do any number of things. And it's very common to see beams. I'll do a little cross section here. So if this is the wall, the rafters were sitting on, they were like this. You can take a beam, set it on top of the wall. Obviously, it's not going to be that tall because it'd stick up above the roof. Let's say it's this tall. And you set it on the wall right here, where my other finger is, and you run it over to this beam, which are both planed with the ceiling joists, right? Okay, ceiling joist right here. That's the top of the wall, bottom of the ceiling joist. Okay, the beam's all in line with that. And you'd hang it on this, and your rafters would basically just come down here and they would get cut off right here. Instead of building this tail out, you would cut it off and do this. And that's okay because like everything's like merging into custom carpentry right in this little spot right here. So little things like that, you got to pay attention, because otherwise your carpenters are going to do something funny, you know. Now, I bring this up because this house was built symmetrically in the front. The same thing happens over here, which I didn't see the first time because I'm just flying right through this guy. But right here, you got the same thing. And so what I would say is, look, we happened to, we took the garage wall, we popped this out 2 feet, and that stays in a line. So I'm just going to say, yep, I'm going to run a beam straight across this sucker. That solves that problem, because now you do the same thing with the beam. You adjust it all. You're good to go. Okay. There we go. Chat time. Green Observer, how much would you say your technical knowledge of framing plays into drafting a plan? Do you try to foresee weird issues, or do you just design and let the builder figure it out? That depends entirely on sometimes what a client wants. When I put plans together, I make sure no matter what, even if there's weird details, that everything's fully defined. I don't want a framer to look at my plans and think, wait, there's a roof plane floating over here in the corner, and I don't know where it came from. I don't know how the geometry was formed. I don't know the baseline. I don't know the roof. I don't know like the wall that it came off of. I don't know the plate height of that wall. Like, no, everything's going to be defined. Now, I will say, I have conversations with my customers when they're getting plans and they're getting things designed about, hey, if you're going to do a big open room and you want to vault the ceiling and it's going to have like a big ridge beam, that's 30 feet. That's going to be a big ridge beam. You know, that kind of stuff. So like, yeah, we talk about those kind of things and the effects of making certain architectural decisions. And I do make sure that everyone is aware that they're not going to design something inherently more complicated than it needs to be into a set of plans. Great question, Mr. Green Observer. Hope that answers your question. Short answer is yes, it helps a lot. Mr. Wyatt MG, I'm doing that same detail in my current project. The beam between rafters I'm referring to. The beam between rafters. I think he's referring to these. Or I don't know. There's a lot of rafters and beams going on here. Maybe he's talking about the pop-up. I'm not sure. But either way, that's good. That's good, Mr. Wyatt. Do good details where things don't fall down. That's what we want. That's why we're here to learn. Mr. Wyatt is a very competent man. If you guys ever need some wonderful things built out in the California area, he is the one to get a hold of. He is making some masterful things happen. And I will vouch for his ability to, like, at the very least, communicate superbly. I do like working with Mr. Wyatt. So if I had a studio shed, if I was in California right now and I wanted to build an office in my backyard, I would be contacting this guy. 100% right there. 100. Okay. So back to the house. What do we got going on here? We got this section. We got this section. Let's approach it. What are we going to do back here? Okay, let's talk first about the back porch. The back porch is a 12-foot ceiling patio and a 12-foot dropped beam, well, 12-foot like plate height dropped beam right there. All right, let's draw the section of what that means. It means 12 foot happens right here. The rest of the house, if it was a house, would mean, hey, 12 foot is the top of the wall. Technically, it'd be 145 and 1/8 if you're using precut studs, but we're going to ignore that part. 12 foot, which means my porch beam will look like this. 12 foot. That way, all of the roof planes, all the rafters are all happening at the same elevation all the way around the house. So what is complicated about this roof plane, I'll turn this sideways, is that we have this beam up here, and then we have the ceiling, and then we got the wall of the house. Okay, this is the porch. The problem is that this thing is at like a 112. That's a kind of an exaggeration, but you get the idea. There's no room in this space for beams and structure and crazy stuff. Like the depth's just not deep enough unless you want to go crazy deep. And if you go crazy deep, you don't need beams. So what we have to do is basically, oh, that's grossly exaggerated. Use some big members that can span for the ceiling and the roof. and do it that way. That's what we got to do. So we'll talk about the ceiling when we get there. But for now, all you need to understand is that the rafters are going to start from this beam. They're going to run all the way to this wall. Yep. This big wall is the first thing that's going to catch it. Now, wait, aren't you putting a whole bunch of tributary load on the wall, and that wall load, that's going to pass down through, and it's going to load this big header over the door? Absolutely. That's right. But people like big things, tall things, and open things in big open spaces, so they get big beams. That's what they get. So that's going to happen for all these rafters. They're going to go clear on through, at least to here. Now, what do we do here? I'd be on the fence. I think because I have to do this like gable. So let's look at the back view of the house. Okay, so I've already got to do this. I've got to frame up this gable right here. Now, what I think should happen, the way I'd probably want to do it, and I'm just a guy who draws paper plans, so what do I know? My preference would be to just overstack this because I want to, I've already got to do the math to figure out how to get the rafters here. And there's like a 112 coming into a 412 and like two different plate heights. I just don't want to do that math. And so I would just copy these rafters on this side. I'd put them over on this side and I'd say, yep, they go down to the wall and they stop. They don't have a tail. But I would do that all the way through, and shoot, I'd probably go to here. And I might even take it all the way to this peak right there. Just because that way I'm just like consistent on both sides of this thing. That would be my preference. I'm going to support this. This is now a functional ridge all the way down. This is a false valley. And this will all be overstack in this zone. Overstack with the 112 pitch on top of it. These will be real rafters going this way. We'll go ahead and make that a real valley because there's no reason for it not to be. These go this way, like this. All right, so that takes care of that zone. Now, to size this, we are probably not using 2x12s. Like it'd be, for a house that's like this, for a pitch this low, it's going to be really obvious if this thing's not flat. And it's going to be a pain to make this thing flat using nominal lumber, like 2x12 stuff. And you'd have to use a ton of it to span this far. It'd be expensive. So let's just bump up to some TJIs. And if we're using TJI, like I-joist material, I obviously don't know the spans off the top of my head. You'd have to check the manufacturer and the tables and all that together. And you would figure out, for the roof load, which in Texas here is going to be 20 live load, 10 dead load. Now, if you're somewhere with a snow load, then live load will be replaced by snow load if it's like 50 pounds per square foot. Then you would use that number instead and use a different table. But in Texas, that's what we're dealing with. So that's good. Since this is a real valley, and that's going to switch right there, we're going to add a purlin in here because we needed that somewhere down the middle, split it up. The longest rafter is going to be basically here down to this valley. That's going to have to be spliced because that's just too long. That ain't going to be one board. So yeah, we'll cut it somewhere in the middle and just make sure the long side is not over 14 feet, which it's not. 14 feet comes from the 2x8 limit. So let's support that, dude. Here, 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 here-ish, wherever. I mean, give or take a little bit. It's all customized on the spot anyway. We got walls. Yeah. Plenty of room to brace stuff off in there. Good support. No problems. So big expensive members here, overstack here, simple up here, but we're going to need two big beams. We're going to simple roof frame over here, simple frame over here, simple frame over here, realistic. We got a beam there, simple on the front, a little bit of overstacking, and then realistic in the front with some big beams in the garage. That is basically how you're going to be looking at this roof plan. Let's talk about L ceiling. All right, so let's just, I think we can, I'm just going to set this over here where I can see it. And you can't, because you don't need to see it. You need to see this. This is the floor plan, but we're going to use it to draw our ceiling plan on it. Now, We got some trade ceilings in this motherfucker. So we're going to deal with these a little bit differently. We've got some different ceiling heights and different things going on. So a little bit interesting, a little bit more interesting this time. Now, the first thing, let's pay close attention. Because whoever drew this was a nice draftsman who cares about the framers, it has been made very obvious where the pop-up happens in this drawing. Okay, there's this beautiful dashed line that represents the exact pop-up, and the exact pop-up is exactly symmetrical and all that stuff going on. I got to get my water. Oh boy, I'm getting excited. Hold on. All right, much better. I didn't choke. I was worried about that. Okay, so ceiling plan pop-up, boom, right there. Now, what that means to me is I have probably the way they're probably going to frame this, because they like to do this, is they're just going to do 10-foot walls across most of it, and they'll do a pony wall up to 12 feet, pony wall up to 11 feet, pony wall up to 12 feet. If this was me, I would build big ass 20-foot walls in this center of the house. I'd stand those up, and then I'd frame around it. Like, that's my preference, because I understand like load passing and lateral and all those things. And maybe that's just extra. Houses don't really fall down often. So 6 one way, half a dozen another. But let's visualize this, because it's actually very important. Now, if we have a 2x6 exterior wall going around this rectangle, and we don't see wall like right here, right here, right here, guess what? There's got to be a beam there. So let's do that. Let's look at that. Okay, so first, we got this corner. Now this is a floating corner, which means either I have a full beam running that way, and then I catch this one, or I got a full beam running here and I catch this little one. I would rather do this because it's a shorter span and a shorter beam. So we're going to go right here, and we're going to say beam right there, baby. Okay, that's going to hold the wall on top of there. We'll put a short guy in here. That's going to need a hanger. Okay, let's keep moving on. We got the same thing over here. So in this case, I could actually run to the fridge, I could run over the fridge with this beam, go to that wall, because that's even shorter. All right, whenever you're using beams, you want to make them as short as possible all the time, because short beams are easy beams. Okay, hanger there. Okay, I got the same thing going on right here. Now, the interesting thing about all these beams is each one of these, they're actually going to define the edge of the ceiling. Okay, so there's going to have like the 20-foot ceilings up here. Then you got the wall that comes down to the regular height, and then it changes to like the 10-foot ceiling or whatever. The beam is literally going to be right here at the corner. That's where they're sheetrocking. They're sheetrocking the beam. So we got those. These are headers inside the wall. So that's just like built into the wall, taken care of. But these are little soffits. Like, these are 10-foot ceiling areas next to the fireplace. So they're technically going to get a beam. But like, if you're building this as one big wall, well, then it's more like a header. It's all the same. Just, something's got to be there. Something's got to do that part. Okay. So that takes care of the pop-up. The next thing I know I've got going on from the roof plan is I got those roof beams from the main pop-up area in the even thirds. I'm going to mark it with my eyeballs and then draw the beams. We're going to do orange on this part. Okay, we're going to cross over about like that. Okay, so that's where those beams are. Now those are up in the ceiling up high at 20 feet, but we want to draw them in because guess what? There's a post inside the wall it's taking that weight down to the foundation. And in only one of these cases right here, the post goes straight into a wall into the foundation. In every other case, it lands on another beam. In this case, there's a header. There will be let's make it blue, whatever. There's a header above this big fat door going across. Okay. So this is a house where you'd really want to have your calculations down pretty good because you're going to concentrate a lot of weight into this guy. Then you're going to put it on this dude and you're going to concentrate. It's just like, oh, there's a whole lot going on. This dude over this door is going to be pretty big. Right now it's listed out as a 114-inch door. I think that's 18 feet. I could be wrong. My math is not always great. It's one of those things. It's a wide door. And so I wouldn't be surprised. It's a 2x6 wall. So there's going to be 3 plies of beam. It's going to be a 16, 18, maybe 20-inch LVL header because you've got all this roof area and ceiling area right there in the center of the beam, which sucks. And then you got this whole patio also loading this thing. So like a lot of weight right there. Okay. We're good. We're good there. How are we going to do the ceiling? Well, all right, there's 2 ways to think about this. 6 one way, half a dozen another. I would probably just run the ceiling left to right because then it's just 2x6s, 24 inches on center. You could easily span beam to beam. And then you don't got to worry about weird stuff. You could run the other way, but then you're going to have to use like 2x12s or something expensive and weird. And then there's like long, and then you got to like brace and it's just a mess. So I'd probably just do that. Yes, it does put more weight on the beams. Like that's the other thing. If you're in a scenario where you've got a big beam like this, and I can run the ceiling this way, and like for some reason I am physically limited on the size of this beam, like I could not use a 3-foot tall beam. It wouldn't work. Then I would switch the ceiling and I'd try to split. I'd get as much weight off the beam as possible in order to use the smallest possible beam. So it'd be good there. There's also a beam over the whole like cabinetry thing here. I didn't like show that, but like, yeah, hey, something's got to define the ceiling over these cabinets. Okay, that's a 10-foot little pocket in there. All righty. Cool. That's that area. Let's do some ceiling over the garage. What do we got going on? Well, the first thing we got going on is there was a beam that was for the roof right here. And then we had one that was like kind of midway through here like this. And then we had another one that was for the purlin, and it came off this wall about here. All right, so those are the beams that exist in the garage already. So let's look at that and think, yeah, I don't really want to run my ceiling all the way across the garage. I don't. I'm just going to, like, I got lots of space for these beams to be big. So I'm going to run a little thicker to both sides of the attic access. I'm going to box out the attic access. Okay, and then I'll just, do this whole thing. And boom, yada, you got a ceiling in your garage. Okay. Let's see. Bedrooms, everything's pretty square. Everything's pretty even over here. So like, shoot, you could run your ceiling however you want. You could run it at a 45. I'm going to do this just because it really doesn't matter. Just pick one. Make sure the span makes sense. These rooms are 13 feet. So like you can go 14 foot with a 2x6, 24 inches on center, Southern Yellow Pine #2. So yeah, run them however you want. Do whatever makes sense. You're going to have to cut them up. You're going to have to cut lengths and stuff. And everything's flat ceiling over here. So it's all planing together. Let's go ahead and just continue that idea through this whole zone. Now, office, dining, they are going to be special. Entry is going to be special. Master bedroom is going to be special. Let's go over here to this dude. Now, we have a gable going left, right here. So I actually do want to run my ceiling joist left to right. And you say, wait, Sam, hold on. There's nothing here. This one ceiling joist is going to be going like 20 feet. Not true. We'll take some double 2x6. We'll put one right there. We'll catch it. It would hold it. Just throw a little hanger on it. Nothing crazy there. Let's think about this area right here. Okay, roof plane's going up that way. We would like to bring our ceiling joists parallel with our rafters along this wall. But here's the other thing. In this case, it doesn't matter because this wall is framed at 11 feet. The ceiling joists are dropped to 10 feet. So in this case, there's going to be a ledger. There's going to be something else. It's going to fur down. Not going to be a thing. So it really don't matter. It don't matter none. So in this case, I'll go this way. I'll do what makes sense. We'll cross the hall the short way. All right. Same thing. Nothing special going on in here. Same thing. This is a big gable wall on this side. We got a gable going on in here. We'll talk about that in a second. We'll cross the hall the short way. And then we got lots of room in here. So we'll just do it that way. Okay. Again, pretty arbitrary. You can kind of pick and choose. Let's see. We got a comment here from Mr. Eduardo. Does it matter the orientation of the ceiling joists? Do we need to align it with the rafters, or can we choose the most convenient orientation since the roof is supported by all the purlins? That is a great question. Hopefully I can answer that for you here. The short answer is it does not matter. The ceiling joists do not have to run the same direction as the rafters. We're going to go into a little bit of a, not a rant, but like a little story time here, okay? Back in the day, it used to matter because we built houses with a floor plan that looked like this. We built box houses, so super simple roof planes. There was a gable on the right, there was a gable on the left, and there was a ridge down the middle, okay? When we built houses like this, like the exception to this is they'd pop out something like this, and then you'd have like a gable and like one valley, okay? But like that's overstacked. They'd basically overstack this, and they'd build ceiling joists and rafters would go left to right here. Ceiling joists and rafters would go left to right here, and they'd overstack this thing, okay? Now, the direction mattered because they used to not brace up ridges like we do now. We brace ridges now because we build houses, very different, custom shapes, all kinds of stuff. The basic dynamic of the job-built truss is gone, okay? What is the job-built truss? The job-built truss is when framers would stack up a ridge board. They'd put a board below it. They'd set up the ridge. Everything would be happy. They would take their rafters. They'd stack up their rafters. And then they would have to make sure their ceiling joists went across here and had a very special heel joint with enough nails to transfer the shear reaction that happens when you put weight up here, okay? And the roof weighs something itself. So basically imagine this, right? So all this weight's coming down. What it's trying to do, if this is your wall and your wall, it's trying to take your walls and it's trying to push them out like this. So imagine if you didn't have the ceiling joist, this would happen. The walls would go, they would thrust out. This used to matter because the ceiling joist had to resist the thrust. That was its job. Nowadays, we don't build these anymore, mostly because people aren't paying attention to the heel joint. There's a table for this in the IRC. How many nails do I need here? It's a function of the pitch and it's a function of how wide the building is, because it's just trying to figure out like how much weight you got going on. It's like roofs, like everything's standard areas. And so if your building is this wide, then you just have a certain load here. So it's all standard. Now, the same was true when you built like really wide buildings like this, okay? You had the same thing. They'd build the ridge, rafters, ceiling joists, but like you got a big long house, so your ceiling joists aren't long enough to go all the way across. So you'd have to splice them. Well, at each splice, as long as you use the minimum number of nails, you're transferring the shear strength across the connection, and the whole thing acts as a system that resists that wall thrust. So that used to matter. That's the long answer, Mr. Eduardo, on why ceiling joist direction can matter if you're being very intentional. Now, today, why would you do this? Why would you design something like this? The key is when you do this, you don't need this guy. Now, this presumes that your rafter can also span that far without bowing excessively. So if you use big rafters, like Mr. Matt Reisinger did a video one time where he basically had a big custom house and he had a big attic like this. And so he used big fat LVL rafters and he used big fat LVL floor joists, and they basically connected the crap out of them in the heel, and they made a job built truss. And he wanted to be able to use this whole space with nothing in it. So that's all he did. Engineer just specified, hey, you just like have this 2,000 pound shear force here. You have to like make sure you overcome with hardware. But that's what you do. So if you want to do that, then be intentional about your ceiling joist. Otherwise, it doesn't matter. Okay. I can build a floor plan view here. Here's a house. The house has a single gable. I can run the rafters this way. I can run the ceiling joists this way. No one's going to care. What are you going to do on this spot? Let's draw a wall section, okay? I talked about this a little bit, I think, on a few streams ago. But here's the top of the wall. If your rafters are going up like this, and your ceiling joist, here's your ceiling line, okay? If you're doing the perpendicular one like this, obviously if they're parallel, the ceiling joist comes in here, connects to the rafters. If you go the other way, then the only thing to think about when you're framing is the pitch of the roof, okay? Because this is a ceiling joist. This is a ceiling joist. This is a ceiling joist. Now, do you see the problem? Do you see what happens? I can only get so close to the wall before I hit the rafter with my ceiling joist. So like the last one could maybe go here, you know, and not hit the rafter. Now, so what happens if this space is too far for your drywaller, and you would obviously turn the board sideways and like put your drywall backing in. But if that gap was still too big, then what you would do is you would not put that one in. You would actually turn and make a bunch of blocks. And like the main ceiling would be going this way, but you would turn and put blocks in that basically act like they were the rest of the ceiling joist. And they would hang right here with hangers on this last ceiling joist. Frequently, if it's a wide gap and there's a lot of weight being put on this one guy, then double up this dude because it's going to carry extra weight. But yeah, you can basically just turn this, go the other direction at the very ends. It doesn't matter. So there's lots of ways to do it. Short answer is, for a house like this, there's no one in this house trying to resist thrust loads. Not in one spot. Now, it could have been, we could have done that super easily up here because there's just a gable and a flat ceiling joist. Could have done that. And if it was my house and I was framing it, I would be comfortable doing that. I'd be fine with that because I understand how the math works. But like you better be like careful if you're trying to tell framers to not put bracing in, because like you just have to know, you know, where to put the hardware in so that the problems don't happen. Okay, cool. Hopefully that was a helpful answer. Patio is easy because it's going to be in line with the rafters. You know, Eduardo, I take it back. In this case, because this roof pitch is so low, yeah, these ceiling joists have to be in line with the rafters. There's literally not volume. There's no space to run these perpendicular. It would just be too thick. So let's talk about the trays. Oh, wait, front porch. Simple, flat ceiling, you know, you go either way. In this case, I got a gable, so I'm going this way. Okay, tray. Now, let's talk trays. Let's remove this sheet, flip over, and let's talk trays, okay? What are the multiple ways to tray? If your room has a 10-foot plate height, and you have a room that says, hey, 10-foot ceiling, tray up to 11. And let's say your roof pitch is a 612, nice and easy. Okay, that's a 612. I'm only going to draw one side of the tray, but you can imagine the other side. Typically, there's only like one side you have to worry about. That's the roof. And the architect dude said, hey, the tray starts 2 feet in from the wall. See that? See how the trays are denoted of this dashed line? 3 feet in from the inside wall framing is where the tray starts. Okay, that's 3 feet because the pitch is a 412. And I'm not, oops, I just markered up my desk. So 2 feet in, 1 foot up. Typically, the tray is 1 foot up. You can do whatever the heck you want, but that's just typically what they do. Okay, so if we went 2 feet in, 1 foot up, that is the new ceiling height. Now, where's our structural members here? We have a rafter. Okay, that rafter's got to be there to define the roof. Now, the reason I said 2 foot standard tray and a 612 pitch, guess what? Math, guys. If I go 1 foot up and 2 feet over, that happens to be the same ratio as 6 feet up or 6 inches up, whatever, 12 inches over. Okay, so when you do a 612 roof pitch and a 2 foot offset, 1 foot trade ceiling, then the geometry works out so that like literally that bottom of the point of the rafter is like the point of the ceiling as well. Now, I have seen many times as an engineer A designer and drafter will not pay attention to the tray, and they'll have a house with a four. It's literally, guys. It happens with people who do 312 and 412 pitches all the time because they're so used to doing a 2-foot offset. Here's what happens: you have a wall. They have a low slope roof. Let's say it's a 312 roof pitch. Okay, they come in 2 feet, and they say, "Yeah, I would like a 1-foot tray, please." Do you see the problem? I hope you see the problem. The problem is that the framer's not going to want to do this stupid thing for every single rafter. That's no bueno. No work-yoli. So what has to happen is if it's a 312 pitch, you got to come over 4 feet. If you want a 1-foot tray. Or, like, here's what happens, guys. People start building the house. They start framing the house. They got the roof in. Then they come in to frame and fur out the tray, and they see that it won't work. And they're like, shit. So either they bring the tray down to 6-inch tray, so it does work, or they bring the tray in 4 feet. Now, here's a funny story. If you build a room like this, okay, and the 2-foot tray line looks like this. This is pretty typical, like proportions for a room. And you've got a fan and 4 cans that have to fit in here. Like so. Guess who's not going to be happy if instead of a 2-foot tray, they now have to do a 4-foot tray offset, or it won't fit. It basically defeats the purpose of the tray. And so typically what they'll do is they'll sacrifice the depth of the tray, and they'll still go like 6 inches. Like, you can maintain the like kind of aesthetic, but like, yeah, watch out for this one because that will get you. Okay. So this is one way to tray. There are other ways to tray. In our case, let's talk about a different case. Now, wait, hold on. Let's go back. People tray framing way different depending on what their goals are. You can box out a tray. Actually, I'm going to show you each one. Let's find one of these examples that's like this. So we have 11-foot wall, 10-foot wall. Here we go. This is the one right here. It says 10-foot ceiling to 11-foot ceiling, a nice 12-inch tray. Step up 1 foot right there. Okay, we got a 3-inch offset and a 10-foot plate. So we literally right here have this example. Now, some people, there's multiple ways to build this. I don't have a way to erase this, so we're just gonna go with it. Okay, I have shown you guys the tray on other plans where you take the ceiling and you just run the ceiling in line with rafters. Mr. Eduardo, pay attention. This is one of the situations where you do have to pay attention to which way your ceiling is running. You run the ceiling in line with your rafters. You nail the shit out of it to your rafter. You put a heel block in here. You nail the shit out of that. So that's attached. You're trying to get solid wood all the way to the plate. Nice stiff connection right there. And then that's your ceiling joist. And then on this side of the house, you made a 10-foot wall and you stacked a pony wall on it, or you just like built the full height wall. Either way, don't matter. Okay, and your ceiling joist just sits on top of the wall. So that's one way to do the tray. Okay, and you would just like fur that down. We're going to do a different way, okay? Some builders like to use beams for trays, and they do that because they're trying to isolate the roof from the ceiling. Now, like, wait, hold on. What? That doesn't make any sense. Why would you want to do that? Okay? Here's why you might want to do that. When the wind blows, your roof plane is feeling lots of pressure. It's getting stressed, okay? It's feeling like, oh, nervousness, okay? When the wind blows this way, it puts positive pressure on the roof itself, and it puts negative pressure on the other side of the house, okay? Pushes the roof down, pulls the roof off the other side. If the wind blows back the other way, it goes back, okay? Now, guess what happens when you're in a windy storm and the wind's just like going all which way direction? Well, the roof diaphragm itself is going to get like pushed and pulled. You know, if you ever seen, I don't know, I could think of a corollary. Like, imagine someone who has a broken window in a car driving down the highway, but they've put like a tarp over the window, and because of the turbulence, the tarp is constantly being like pulled out and then pushed in, then pulled out and pushed in. It's being shaken all over the place. Imagine that happening to your roof, and your roof is connected to your sheetrock right here. Okay, that's a joint, and this part's pretty fixed to the wall, but that is a joint between your ceiling plane of sheetrock and a new plane of sheetrock, a paper joint. Okay, and what you don't want to do with that joint is go, just like that. You don't want to do that because it's bound to have a problem. So some builders will not do this detail because they've had that problem. Don't ask me. I haven't lived long enough for that to like know what that's about. But it's just like I got the concept in my head. So what they'll do instead is they'll leave the roof totally separate, and they will beam out the tray. They'll do this. One beam sits on the wall, and it runs, and it hangs here. Now this is more expensive because you got to buy beams. Another beam beams out the tray, goes there. Okay. Now the benefit to doing this as well is if you do this, these rafters have to get bigger because you're putting more weight on them right there from the ceiling. So if you do the beams, then the weight goes straight to the wall and you're not doing anything different to your roof. It's kind of nice. And then you'll basically beam out this side and this side. And you would use little hangers here, 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 and here. Okay, so use structure to make your box. And then you just fill the rest in with blocking. Little ceiling joists. Okay, that is one type of tray. Now, the rest of our house actually has a third type of tray because our plates are higher. So all of the other trays we have in here are, let's see. Yep. They're all fur down trays, I believe. Well, this one's kind of could be either one. This one's going to be a combination. So here's what happens. This one's like on a fully interior thing. There's no roof plane doing anything here. Here's what a fur down tray looks like. We're going to talk about the master bedroom because that's where this thing is mainly happening. Okay. So we have a master bedroom with a gable, wall, wall. Pretend it's all even. Okay. This is 11 feet. That's the roof plane. It's been defined. The wall's built to 11 feet. The roof goes on top. The ceiling tray in that room says it's a 10 foot to 11 foot tray. So why? Why did that happen? Now, here's two reasons. It was a design choice is what it was. So if I do an 11 foot to a 12 foot tray, which I could have done, I have to fight the 412 roof pitch. And I would have a room that looks more like this. This is really a really small box for the dining room. That's a little more appropriate because like the dining area is very focused on what happens right here. So that's like, okay, there's going to be pretty much one light fixture that goes in the center of this thing. Not a big deal. In the master bedroom, there's more space in here. You want to make the whole room feel bigger. And so I decided it's better to basically have an 11-foot ceiling, but pop down the edges to 10 feet versus have the whole thing at 11 and pop up a small block in the center to 12. I was going for a different feel. Now, technically, one of them gives you more volume than the other, but we're going for like what the space feels like. And you're not going to notice like a foot difference per se. That's why I did that. But I wanted to keep the 2 foot offset. Like that was the main thing. So what we got is the tray needs to happen. Use a marker. Tray needs to happen down at a 10-foot mark. Hey, what are the odds that I like line those up pretty well? That's pretty cool. So that means that is fur down. Super simple. Your structure doesn't change. You're just going to use a bunch of blocks combined together, and like you're going to fur down the framing and create little chases to create the shape of the ceiling. The actual ceiling exists up here, and it just runs wall to wall. Super simple. So the ceiling structure is not modified in this room. I would just take the ceiling and go like this and say, hey, is this, where's my quarter? Is that less than 14 feet? It's a little bit over 14 feet. So I would say, hey, these ceiling joists are going to be 2x8 in this room, 24 inches on center. And then I would say, hey, fur down. Oops, that's not the right cap. I'd say just fur down the entire tray. I'm going to say the same thing in this room because it's the same. And the same thing in the entry. The whole structure goes across, and you fur down the tray. Now, lots of ways to do it. You could do it another way. I don't know which way the framer is actually going to do it when they build this house. Who knows? But like, this is kind of how I would approach it. So we got the whole ceiling plan. We got the beams. We got the hangers. We didn't really talk about headers, but you guys know what headers are. Your headers are going to go on your walls. Everywhere there's a window. I'm not going to do all of them. There's so many. A window or a door. You're going to have this header in here doing stuff. Also, pay attention here to the garage header. Now, actually, we're not quite done. Look at this. All right. You've got this beam and you got this beam. All that roof sitting on that. And it's all sitting on this garage header. All right. Let's take a look at this. That is a 16080 garage door, which means garage door header height right here. This is the symbolization of the header. This is the beam part. 8 foot at the top of the door, which is, there. Now the whole thing is going to drop 4 inches because the whole garage slab floor thing is sloped and the door itself drops. It's 8 feet tall from the bottom of the drop. So 8 foot tall the door, and my plate height right here. I want to know what my plate height is. So I'm going to look. What did I do? I did this whole front thing with a 10 foot, I think. Yeah, these roof planes are 10 foot plate heights. So what that means is that up here, well, actually, it's probably most closer to like here. 10 foot plate height. Now, I intentionally left 2 feet of space between the top of the garage door and the plate height. If you got to be careful when you're doing like really big headers, if you generally don't want to have like a 9 foot tall door to a 10 foot plate or a 8 foot tall door to a 9 foot plate. It's really hard sometimes, especially if you've got a house that puts a lot of weight on that header and it's a double door, to like keep the header small enough. And I've literally had to see, it looks so weird. Okay, I'll draw one more little doodle for you guys. Okay, I got a call from a builder who's building somebody else's plan. This is back when I was an engineer. All right, so here's what they did with the garage door. Plate height required was like probably 10 foot for the roof. Garage door was a 9 foot tall garage door. And the beam header that us as engineers specified to structurally do all the things it needed to was like an 18-inch header. What does that mean? Well, it means they got real freaking close to having something really stupid looking. Basically what happened was they were allowed to drop the header like 4 inches because the garage door shifts down 4 inches when you drop the slab in the garage. All right, so they had a little bit there. And basically what they did is they had the beam stick up above top of wall plate, and all the rafters that went through that one spot, right? Because this is typically, this blue is the regular top of wall. So all the rafters looked like this, except where the beam was, they had to do a special notch for all those rafters. And like they were barely able to keep the beam hidden below the roof plane. So yeah, watch out for that because you don't want people finding that. That is no fun. So here you go, folks. Hope this has been useful. Another good old Frame It Fridays on a nice big custom home. We'll see what comes up next week. I've got all kinds of things that run through here, so Who knows what it's going to be? But thank you all for coming on. This has been super fun. Thank you for chatting. Hope this has been helpful to everyone. And I will see you again on the next week. As always, let's take it out with some music by the one and only Green Observer.
That's the code.